organizes and sponsors what we call it the Learnings for Economic and Policy Analysis Series, or LEAP events. The idea here is to keep these events quite simple, straightforward, and very participatory, and allow the exchange of knowledge across ADB and even with people from outside. You know that we have organized already two. It's a new initiative that we launched at the beginning of this year. In January, we organized one on vaccines, a vaccine facility, especially on the AppBacks. And then in March, we organized one on poverty mapping using big data. So we try to keep this not very technical, so you don't need to have any particular knowledge about the topic. We also trying to keep presentations quite short, at the maximum about 20 minutes, to give a lot of space for the audience participation. So I would like to encourage everyone to really participate, ask questions in a very informal setup. Today, we are very lucky to have as moderator of this event to Paolo Manunta. He will be moderating this and introducing the speakers a little bit later. I think we have a very interesting panel today. Paolo is from SDCC, the Sustainable Development and Climate Change Department of ADB. And he's also actually the European Space Agency on-site expert at ADB. This is, I think, it's going to be a very interesting topic. I think Paolo has actually 20 years of experience in this field of satellite Earth observation and related applications. And he has been contributing and managing the public and the private sector projects that make use of Earth observation, spatial data infrastructure, and also thematic exploration platforms. So that's I think we're very lucky to have Paolo today, and he will introduce the speaker later and discussions, and also guide you through this discussion. So thanks very much. Paolo, thanks again for joining us, and the floor is yours.
Thanks, Alfredo. Actually, the pleasure is mine. It's a big honor to be part of this event today. Also because the European Space Agency has been working with ADB since 2013. We are helping with about 30 projects. But I have to say that CERD is actually our really champion user department. I've been working together with several of you, and I define you as the champion users. We're working with Eric in Indonesia, Stefania and David and Timor-Leste, a lot of work in Cambodia with David and Alvin. So we have a lot of things to continue working on. Today, I want to mention before a little bit the rationale for the European Space Agency to have having this partnership with ADB. A few years ago, the European Commission and European Space Agency decided that the best way to streamline Earth observation was to ensure a free and open data system streaming. What does it mean? A lot of money has been invested, about 8 billion euros, into a space segment called Copernicus. Copernicus is a free and open data system delivering about 17 terabytes of data every day globally. So data is free and open. But of course, there is the challenge. I mean, like, as you can imagine, we cannot think of looking at the image, the same way we do with Google Earth. We need to extract the information. And feature extraction is not an easy thing. And that's why we rely a lot on partners like the group of today, which we call that, value-adding services. They extract the value from the raw data. And today, in particular, they will present us with a cocktail of megatrend, technological megatrends. As you know, everybody is talking about big data, and today, we have an example of big data being Earth observation, but also very important, machine learning and artificial intelligence, also combined with other sources of information. I will not take much time to talk about this. I will briefly mention the three contributors of today. Laura Moreno, with more than 15 years of experience in charge of EarthPulse, a startup, will be presenting. But there are also two other contributors. One, Pedro, specialized in artificial intelligence, a little bit the engine of what you will be seeing today. But also very important, the contribution of Ana Perez. She has been involved for many, many years in streamlining applications into final end user, final end market. And she's also an expert in big data, which not necessarily relate to Earth observation, additional data like Facebook and such. The floor is yours. We will be flashing a couple of questions. Those are yes and no questions, but are meant to stimulate the discussion later on. I think Dulce is flashing those in the chat box. So the floor is yours, Laura. So please take us to this technological trip into Earth observation in Cambodia and Timor-Leste.
So can you see my screen now? Yeah?
Yes, we do.
Okay. So, well, first, hello, I'm Laura Moreno, as Paolo introduced me. So thanks, Paolo, Bernard, and all ADB organizers. It's an honor being here today. Thanks for the opportunity. And as Paolo said, we'd like to show you how it's possible to use satellite data for decision making. So here we go. So briefly, I'm going to introduce EarthPulse in just one slide. That's exactly what we do. We are trying to extract the information and the value that it's inside the satellite data for decision making. And to do so, we specifically use AI. So cost and complexity of the whole processing of the whole thing are very much decreased. We are going to show you how and a practical example. So first, I like to speak and talk a little bit about how and why is that maybe useful for you. So in the middle of the climate crisis and economical and social crisis, we all need to take decisions based in data, because we need trustable indicators to overcome the social and the economic vulnerability that we all have now. And sometimes models aren't accurate enough, and IoT data many times is expensive to deploy and expensive to maintain. And for example, if you want to see or to assess things happening in one area like yesterday and there is no IoT deployed, you have no way of knowing what happens. And satellite data can really be useful in that context. So we have the satellite data, a lot of constellations during the last years. There has been an increased launch capabilities, and we have a lot of sensors, different resolutions, everything comes with a big data. Satellite data is big data. It was something that was not very frequent before, and now we have global coverage daily, basically. But as big data, it comes with complexity. The volume is very high. The velocity and the variety and the veracity of the data makes this data complex. And so that's the reason why this data is so unexploited, okay? So, as I said, the EO data is very useful, it's fantastic because it's frequent, consistent, independent. And another very good thing is that we have a very long archive of historic data. So we have data today, but we have data for the last year, for the last 5 years, etc., and even for many other years, okay? So, in the other hand, we have artificial intelligence, which is like the transformational technology of our era. It's now disrupting many sectors. And so we're going to show you how it can also be an advantage in this sector and how it can be helpful to exploit the EO data. The artificial intelligence is basically the key enabler. So, for example, imagine that you have this kind of area and you want to do a segmentation or a detection or a classification. And that may seem simple to do because that's a very small area with a very high resolution, okay? But now imagine that you want to access a super big area. Then the processing may take a lot of time. And also, if you want to assess something that is happening through the time, you may have to assess that in 1,000 images or something like that. So you absolutely need to automate the processing and to rely on segmentation and detection models, classification models, and you have to rely on AI to be able to process and extract the information contained in big areas or many images through the timeline. Okay, and that's where the power of AI shows up. Okay, so with that in mind, we're going to show you, the methodology we follow and the outputs that we are able to extract. We provide pulses, which are aggregated indicators based on satellite data and in other metadata, and generated with deep learning algorithms. To start, the only thing we need to know is what is the problem, what is to be assessed, where, and when. And that's it. With that, we gather all the EO data, all the satellite data that we want to process. Then we explore the metadata like the IoT, the crowdsourced data, the open data sets, everything, and we mix it together with this EO data. We take all these data sets and we process it automatically with AI. And then we extract the information and put it nicely in an output. Okay? I think that may sound abstract, but here we have some little examples. And the flood impact, it's the one that we're going to explain and to show all the results now. Okay? So for example, here we have the industrial activity pulse. That means that if I want to ask what happened during COVID and how it's been the impact and the recovery in one particular sector, like vehicle industry, for example, or any kind of industry, what I'll be doing would be selecting all the factories, analyzing indicators that talk about industrial activity, like the car occupancy or the smokes or anything that it's like a proxy for industrial activity, compute all these indicators together, several areas, several points, several times, and then I'll be able to plot something like you see here, like the impact of COVID and the recovery, okay? For the flood impact pulse, as I said, we are going to talk now about, so I'll go to the vulnerability analysis pulse, and those are just some little examples, okay? So for the vulnerability analysis, the thing is different. It's like, okay, I have a given area, and I want to know where my most vulnerable assets are, and how do they react to different hazards. So it's a point analysis and an environment analysis around some points in order to understand which are the more problematic points of different assets, okay? And then we have the flood impact pulse, for example, that we've been conducting this study in Cambodia, okay? So here we were asked to evaluate the damage caused by the storms and natural floods last October in the Banteay Meanchey, sorry for my pronunciation because I don't know how is this pronounced, in Cambodia. And so we selected an area of interest that is that yellow rectangle, an area of interest inside the province. It's not the whole province. We saw that the events were like here in the middle of October and by the end of October, and we selected some images to be analyzed, pre-event, one during event, which is the 20th of October, and one in November, one in December, like post-event, okay? Then we decided to compute some indicators for that images. So water extension, and for that we use Sentinel-1 and Sentinel-2 images, which are from the Copernicus constellation that Paolo was mentioning before, and open and free data, okay? Then With that, we compute the affected crops, we classify the terrain, and we compute the affected crops over these Sentinel-2 images. Then we took a look to the affected infrastructures, and we selected transfer, health, and education. And for that, we use humanitarian data exchange datasets and open datasets. For every asset, we've been conducting like a study and a selection over different datasets and selecting like the best one somehow and the most recent one as well, okay? And then the last indicator we computed was affected population, okay? So people and households mainly, and for that, we were merged the water extension with the open datasets of Facebook, which were like the best for population, and the dataset like the Census Cambodia dataset as well. Okay, so I'm gonna show you now in a nice dashboard, like a little bit demonstration of the indicators we compute. Can you see the dashboard now? Yeah. Okay.
Yes. Yes.
Thanks. So this is the dashboard. Okay. Those are satellite images. Okay, Sentinel-2 images, and this is the timeline. Here we see where the floods were. That's the first date. The first image is this one and corresponds to that part of the slider. Here we have a slider where we can see the image of the pre-event, like 26th of August. And here, if we select the second one, this image, we are going to compare the first date with the second date. And we can do that comparison like visually with the slider, okay? Those two are pre-events, so nothing kind of happens. And here, the third one, it's like like in the middle of the two biggest events. So, I mean, eventually, already you can see already, like the flood extension here, okay? And those are cities and roads, etc. Okay, but now let's see how do we extract the information, because with AI and with this data extraction, what we are able to do is like the computation, the numbers somehow, okay? And here we have the fourth image, which is positive and etc. But let's go to this date, which is the worst one, okay? So first, we have the water extent layer, okay? And here we see how this area is mainly flooded, okay? If you click in the rest of the images and the rest of the dates, you'll be loading the other images with that layer, and you'll see how this flooding it's kind of disappearing. You will see it better in the last one, and we selected 5, but many others could be selected. You see here that it's already kind of disappearing or being reduced more than disappearing, okay? And so here, this one is the flood layer, the water extent. And here we've computed the impact on different things. Crops, displaced people. Displaced people means that their house has been completely flooded. I mean that they have to go mainly, okay, because the house is like completely flooded. And then we have affected people. Affected people is like the top of their house isn't of the flood, but they have a lot of flood surrounding their houses. So that's displaced people, worst, and affected people, okay? Then roads, hospitals, schools, and students, okay? So if we start with crops, we see here the crops classification, and the red areas are the affected crops over the different dates. You can see in a very simple way these crops. And here at the right of the dashboard, what we can see is like the total number of crops, the not affected number of hectares, and the affected number of hectares. which here in this aggregated pools, in this timeline, you can see for the different dates, the percentage of affection of in every asset. Okay, so if we go to crops, which is the blue line, we see that 20th of October, half of the crops on the area were affected. Okay, and here, I mean, these lines are static. They don't change because you have all the dates already in here, while these computations, of course, change over the different dates. Okay, then if we go to displaced people, happens like the same. Here is the displaced people and the displaced households, okay? And again, this changes with the dates, yeah? Then, if we go to the, and you can see here the percentage. If we go to affected people, happens the same. Here in the slider, you can see the affected people, the affected population is like the red small dots. And maybe it's not that easy to see that the not affected ones are black, really black, I mean, really small black dots in here, okay? And you see that evolution through the days, okay? For the affected roads, we can see the same. In green, you have the not affected ones, and in red, you have the affected ones. And here also, as the data set was quite complete and permitted that segmentation, we know that we have two main roads affected and 67, which were other type of roads like secondary roads or not paved roads, etc. Okay, so any other type of road and two main roads mainly. Okay, and again, if we go to the infrastructure, like the health infrastructure now, we can see how these three main hospitals were affected by the flooding, and the three of them were referral hospitals, while the other not affected were health posts of the area. Okay, you can see green and red, and you can go through the dates and see that this one remained affected while the other two quickly recovered. If we go to schools, okay, if we go to schools, same thing happens here. We can see how many schools were affected, and we can segment over like the preschool, primary schools, lycée, and college, the total number of schools and the affected ones. Okay, so quite a high number of schools were affected, mainly primary schools. And the data set we used was explaining and was detailing how many students per school there were. So we just put in here as well the number of students affected per day, okay? And you can see that, of course, the primary school students were like the most affected. And well, that's a little bit all for the demo. And I'm going to come back 1 second to the presentation and finish now. Okay, those were like the computation of the numbers in the different dates, like October 20th, November and December, and like the recovery of these indicators. And then we were asked to do something, and I mean, we knew that a couple of weeks ago there were floods in Timor-Leste and Indonesia as well, and we just selected the capital of Timor-Leste in order to extract the flooded area. We didn't validate very much this processing, so we're going to show you here in the presentation, and it's not included in the dashboard. And we extracted as well the flooded area, the affected number of roads of the capital, Dili, the affected hospitals. We can see just one of 6 was affected, and one of the 19 schools of the capital were affected. This is the affected one, and that's basically it. Like, I mean, what we have quickly done for Dili was just those 3 indicators: affected roads, hospitals, and schools. Okay, and that's my final slide for today. Like, the key takeaways that we have to keep in mind, it's like satellite data provides evidences of the impact of the damages caused. AI is a key element to quantify and make the whole thing scalable, okay? And the combination of satellite data with other open data sets or crowdsourcing data sets is a very innovative approach to create aggregated indicators and provides nice information for decision making. And well, that's all. Thank you for your attention. I hope you find it interesting. And now we will open the turn for questions and answers. Thanks.
Thanks a lot very much, Laura. I think there will be plenty of questions. I think it's just a matter of breaking the ice a little bit. Just before we open the floor for questions, let me say that, you know, in my previous mentioning of a cocktail of technological megatrends, we should also add, you know, computing, you know, cloud computing and analytics. As you know, analytics are very important, you know, because usually when you talk to space people, the tendency is to read the map, which is good. But in this example, we have seen that, you know, the map is on one side, but also the analytics is actually provided, you know, by the platform and by these computational assets. I would like to now give, you know, the opportunity for questions. Please don't be shy. Otherwise, you know, we can go and look back and look at, you know, the results of the questions we flash to you, Dulce. But let's see if there are if there is any question at the moment. Yes, we do. Please go ahead.
Is that me? Hello?
Yeah,
Hello.
we can hear you.
Yeah, great. Thank you, Paolo, and thank you, Laura. I just have 3 questions for, first of all, it's a very impressive presentation. Thank you very much for the information. I have 3 questions. The first one is, what is the indicator to measure the inundation? So when you say that the hospital, roads, and people are affected, by what you measure they are affected? For example, the depth of the water, or there must be a threshold and an indicator you use to determine whether an infrastructure or a human being is affected or not. So I'm interested to know that indicator. The second one is, I understand that you use those open data sets for social and infra database. I just wonder how often they are updated. So how can you understand how, or to what extent you can understand the precise impact from a disaster? And the third one is, the satellite camera, is that a visual or it's a radio? Or in another way, I'm interested to know whether you can tell the disaster impact during the formation of a disaster. Because if the satellite camera is a visual, so when there is a cloud coverage, then you cannot see the information on the Earth. But if it is a radio, probably it can estimate the the physical impact from disaster. So it can give some early warning on the potential impact during the formation of a disaster. Thank you very much. I forgot to introduce myself. I'm JC. I'm an urban development specialist with a focus on climate change from East Asia Regional Department. Thank you.
Thanks a lot. Thanks for your question. Juan will start answering the first questions, and then Anna and also myself will add some things for the second and the third question as well. So go ahead, Juan.
Yeah, concerning I am Juan from EarthPulse. And concerning your first question, yes, right now we are considering an area around our assets. Like, for example, in hospitals, we are considering an area around the hospital, and we are saying, okay, if we have more than X flooded area or with water, we consider that that hospital was affected. Of course, this threshold, we chose one that we thought it was okay, but that's something that we also have to validate with the interested people to choose the best threshold. But our objective in the end is to, as we already said a couple of times, we are using artificial intelligence, and we want to automate this process as much as possible. And one automation is to give the power to these models to already say if an asset is affected or not. So we will add in our data set, okay, this hospital was affected. I don't know how much, or maybe we can quantify this, but by the process of training these AI models to say that one asset is affected or not, we would remove this uncertainty or this threshold optimization problem from the table. So that's our objective. But now, yes, we are considering an area around the assets and using a threshold. Considering your last question about visual or radar, we are using both, okay? We are using Sentinel-2 images, which is a visual optical satellite, and Sentinel-1, which is a radar. So whenever we find clouds, of course, we cannot see what's below the clouds on Sentinel-2. Then we use Sentinel-1 to provide this information that's missing from the optical data. And the second question was
about the open data sets.
The open data sets, yeah, if you want to take this.
Anna has been working more on the open data sets, so I think Anna can answer you better.
Sure. Yeah, for the open data sets, the information we use combines information from one of the also big trends that Paolo explained before, this data for good. What we done is to compile information from different public data sets. Normally they have been updated yearly, in some cases monthly. What we done is to compile the most recent one that we can validate, for instance, the population. So Facebook is offering this data for good package. And what we have done is to validate with urban footprint, also to validate exactly that it is a good data source. And basically is what we've done with all of them. We try to choose the most recent one. As I said, normally they are created or yearly, or in some cases monthly, and we integrate this validating previously with ground truth data.
Yeah, and I want to add a last thing on this point, that of course we would always need metadata for some things like the number of students in a school. That's something that we cannot easily estimate from satellite images. But there are a lot of other information that we are using metadata right now that in the future we can directly estimate from images, like if a building is a school or a health post or something like that. We trust that in the future we can also give a good estimation of these kind of assets directly from the visual features that we can extract from the images.
Great, thanks. More questions from the audience?
Hey, Paolo.
Hey.
Ramesh here.
Hey.
Thank you so much, Laura and team. This is very, very informative. Thank you very much. In your last slide, you have a reference to open data sets. The combination of satellite data with open data sets is an innovative approach. What type of open data sets? The quality of open data sets is quite important, right? So if you don't have good quality data, does that have an impact on the quality of assessment? So from our ADB point of view, as you know, we are working with many countries. Anything that you've seen from practice that we can use as a guide for helping countries and kind of harvesting this type of data and putting them out in the public domain?
No, sorry. Yeah, Well, it's sure. I mean, it's clear that the quality of the data sets it's very important for the indicators computation. Okay, as Anna said, what we used was really quality verified data in the open development data sets and the data for good exchange, and we cross-validate that also. For example, the population one with the urban satellite layer. Okay, so I don't know if I understood well your question. I mean, the quality of the data sets, it's like, of course, impacting in the final results. We cross-validate as much as we could the quality of these data sets. And also, as Juan mentioned before, not now, but in the future, when the full models work and this is like more automated, we will be also able to compute some data sets as well and share them.
Yeah, thank you. The question the example that I had in mind was the Timor-Leste mapping that you have done. So there we are doing a damage and loss assessment right now. Mm-hmm. So for us to decide, the best possible manner in terms of moving ahead, what have been the damages, what type of reconstruction would be needed, mm-hmm. What do we need to see in the open data set? That's my question.
Yeah. In fact, for the flooding impact pools, the one that we discussed today, mm-hmm. the data coming from the humanitarian action from the United Nations is one of our main data sources in terms of infrastructure. So these are data sets that have been also used in previous actions in order to identify, schools. As Juan said, we cannot right now, probably in the future, but right now we cannot detect the building that is a school compared with others. So we are using this what we call open data set, but an open data set is also Copernicus. I mean, is open, and what we check is how this is trustable for the other data sets. So we compare previous actions that have been done using these data sets and also on the ground. I mean, we can zoom in to understand exactly, this is the building we want to highlight, or these are the roads that, if a data set contains roads that are not within the evidence that provides this satellite, is not validated from us. So there is the data source and then the check with our validation. But also, they are not, let's say, sorry. Yeah, no, go ahead.
I was saying that for these flooding pools, what we use, as you could see, was hospitals, roads, and schools. Okay, and population, and so then we can assess the impact on those things. But in the open data sets, there are also more things that could be potentially included, and if you include them, you can assess the impact also on those assets. Okay, so potentially you can include all the data sets, and it's possible to assess the impact on those assets. Like, I don't know, I don't remember, Anna, because at the beginning there were like more things that we found, and we decided together with Paolo and Bernard to assess those indicators. But if you include other metadata regarding other assets, you can include other things like the impact. You can assess the impact of other things. Like, I don't remember if you have something in mind. Yeah. For example, in Cambodia, we analyze more things.
Yeah, in Cambodia, we assess as well the wells location. So for water, so which the location of the well, and also the landmines, some landmines to identify potential problems in these areas.
Yeah, maybe very briefly also I can add, Ramesh, the other source of open data they mentioned briefly refers also to the Copernicus Emergency Mapping Service, which, for Timor-Leste was not taken into account. But for example, in that kind of data set, is the same we use when we started to work in Paolo for the reconstruction. There is a full data set with a grading system of damaged assessment done on buildings and infrastructure. In other words, there is a starting point where we can find out which buildings have been affected and how, in a sense that the building can be partially destroyed, partially damaged or totally damaged. Of course, with flooding, we need to be very careful because, flooding not necessarily destroys the building as compared to an earthquake, but still, we know the amount of infrastructure affected by using that data set. So maybe, for the future work, this one is to the team, you can consider, the EMS data set, which is coming up. I just checked, it's not fully finished, but, we know that there will be some data there. We have other questions. Yeah. I think I don't know who wants to go first. If Kavita or Samir. Kavita, you want to go first?
Sure. I just wanted to add to the discussion, basically, to also just say that the World Bank, has done this geospatial mapping for poverty mapping and gender sensitive also. So this would be an interesting layer to add to this. So it was really interesting to see that last slide. I understand you got the information about the damage to infrastructure from the UN reports, but it would be interesting to kind of add this layer in as well, and that would also throw light on the density of people and also the poverty level information. Thank you.
Great. Thanks, Kavita. Samir, you're next.
Sure. Yeah, actually, it ties to what Kavita just said. So thank you, Paolo. First of all, I want to just thank Laura, Juan, Anna, and team. Excellent presentation. I just wanted to understand, a little bit about use of this data to look at the impact on livelihoods, right? So it's clear to me that the impact when it comes to sort of understanding, the post-disaster needs assessment or after disaster, right. That it's clear to me, right, that the usefulness of this data. What I'm trying to understand is in terms of livelihood. So, of course, linking up with the traditional databases, right, on your labor force surveys or income and household income and expenditure surveys, that would be kind of important. But of course, those are not done very frequently. So can you talk a bit more about this? Like, how useful is it in terms of understanding the impact on livelihoods? And can you give some examples from countries in our region? Thank you.
Okay, I'd like to know, if possible, what do you mean when you say livelihoods? So I can better answer. Like the way the population lives somehow, like the type of economy they're based in, or exactly what do you mean when you say livelihoods?
I'm thinking of more on the sort of access to jobs, income, poverty, living standards. So not going more beyond your physical, sort of a non-physical dimensions of life. So that you can't capture through an image.
Okay. Well, let's see. Also, I asked a little bit with the Kavita application as well. We selected the flood impact and we decided to aggregate those indicators to compute the flooding map pools, okay? But before that, there was a reasoning and a work done with Paolo and Bernard, where we presented as well different types of analysis that we could be doing in the area. Poverty mapping, as well as is done with the United Nations, etc., and with the World Bank, etc., is something that can be kind of assessed. We can provide like more indicators to complete like the poverty mapping or the low income mapping or something like that, because you can compute indicators that aggregated together deliver some information on that. No, like for example, the lights, the night lights that there is in a given area, the electricity, like the power lines, how much, I mean, how many they are, etc. Or even you can count it, I mean, classify the urban areas, like the type of houses you have in the area. You can quantify the number of factories and industries of an area. And so those kind of assets will be talking about the livelihoods, be talking about the poverty level, etc. Okay, and you can also compute with external data like metadata, what is happening in an area and how it recovers. For example, something that we have been doing in Madrid a couple of months ago, there was like a heavy snow in the whole community of Madrid. Okay, so we decided to map how this cleaning of the streets and roads was done and how fast and how efficient it was done, and we crossed that together with the average income of each population in order to see a little bit if the average income and area was related to how quick they recover or cleaned the population around. I mean, there are many things that you can cross-correlate and that you can understand by relating to different data sets. And there are many indicators that could be proxy for other things, of course. So you can, the good thing and like the beauty here, it's like that you can mix and as many data as you want, and as Paolo said, that enables a lot of data analytics on the top of it. So I hope I have answered your question.
Yeah, just briefly, you know, just to complement on what we have been discussing. I don't know if Kirishi is here and it feels like contributing, but together with ERCD, we have been using data to define, to measure the wellness, you know, in the city. What we have done is still connected, I mean, like somehow to physical aspects, but what we have done to compute, you know, the wellness index on urban areas, we provided, you know, urban footprint, of course, but also amount of green areas in the city, which affects the quality of the people eventually, and also consistent measurements of air quality at the city level. And as you know, air quality, you know, can change quite a lot depending where you are worldwide. But we can follow up on this one if you're interested. I'd rather give the chance to. I think there are other observations on. I think there was a message in the chat.
Paolo?
Yes.
Yeah, maybe we can show the results of the poll.
Yeah, why not?
Okay, Hannah, please. Thank you. And we also have questions on the chat box if we have time for Paolo. Thank you.
Okay. Okay. The first question, of course, you know, like everybody got pretty much the point. The reason why we had this question is just the other day, you know, we were talking to our Indonesian colleagues, and including Lapan and Bapenas and several of our stakeholders, and we just estimated that to do the historical flood mapping for the whole island of Java, we will need to download 30 gigabytes of data, as opposed, you know, like to use cloud platforms, you know, to do the host processing and downloading the final results, which is only as small as 250 megabytes. So basically, you're all correct, you know, like using cloud platform, assuming that we have the algorithms there, is actually the best choice. We can go to the second question. Yeah, of course. This one is this is no brainer. I mean, you knew this beforehand, I guess. But during the presentation, you probably learned that the ideal combination is optical and radar, and that was the first question, indeed. But also other sources of big data. The boundary of big data is basically, I'm not saying it's endless, but it's actually quite vast, because we had several suggestions for the audience, including livelihood and also other data set produced by other organizations. We have more questions in the chat box, I think. Do we?
Yes.
Please go ahead.
Okay, can we use the tool to monitor rainfall and potential danger during the year, particularly for farmers? Well, it can be assessed, like, for example, something to assess in the with satellite data is like soil moisture, and it's like how the crop's affectation is, like flooded area or just very moist. So there are many things that can be and that have been done already in the agricultural sector. There are many indicators, and yes, it's possible to monitor like the affectation or danger of rainfall, and of course during a particular year, just by analyzing a big time series of it. So would be yes, this question. The next one from Janet Veronica is also this is possible, allowing microfinance institution to assess the damage of their low-income clients, often in fragile dwellings, and preparing appropriate post-disaster responses. As well as said, yes, because you can be analyzing like the kind of area you want, or even point areas, and also you can assess, as I said, those indicators, or we can define together the indicators that we want to assess the impact on. So yes, it's possible to assess the damage in any kind of location, and if we mix together the damage that it's been done in a population with the income level of this population, we can just spot the damage for the low income areas, let's say. Then another question here from Sheila is, can this technology differentiate between flooded vegetated areas, urban covers, and polluted waters to prevent any possible underestimation of damages or impact? Yeah, I mean, the flooded areas, you can, it's already here. I mean, we've shown how the flooded areas, I mean, we have the classification on the urban and on the crops, and then you have the water extent. So you can differentiate if the flood is impacted on urban area or in the agricultural or crops. Then the pollution of the water is something that, for the extent of the flood, I'm not sure it's possible to be assessed, because in order to know precisely the water quality of an area of water, the depth of the water should be normally more than the typical one in floods, but it's something it could be tried and see. The results should be checked, because I'm not really sure in my experience if that will be working here. You can maybe compute something like total suspended matter, or like the type of color, water color that has the flooded area, and from that extract some conclusions. But the typical parameters for water quality need a depth, a concrete depth that it's I don't think would be enough. But what you could see what will be like the water color somehow.
In this point, I would like to add that the kind of models that we are using, these deep neural networks, are very, very flexible, in the sense that we only showed like very high level layers like water and crops, urban and so on. But you can go as deep as you want with these models and give different kinds of urban, different kind of crops, different kind of water layers. Like river would be one layer, the sea would be another, lakes would be another, and flood that causes damage can be another label or layer. So as long as we have the data to train these models, we can go as deep as we want in this sense.
Yes, thanks. I'm sorry to interrupt, but it's part of my duty to make sure that we are on the right time. There's
one more question from David.
You wanna take the one from David? I saw it now. You see that? Okay, please go ahead, and then we'll wrap up.
Well, David was asking about the frequency of the mapping. Okay, like that it seemed low because it was like 5 images. We just selected and decided to do 5 images, but and we just selected the Sentinel data. But just the Sentinel data, Sentinel-1 is like every 5 days you have image, and Sentinel-2 you have images also every 5 days. If you combine the two together, you'll be having an image every 2 days more or less. And that's just what's Sentinel. If you open or you want more data sets, you have really frequent coverage. We just selected 5 images for the proof of concept, but you can, the frequency is very much higher.
And also, as I was mentioning, the flexibility of these models giving predictions, they are also very flexible getting data in. So we are designing our models from the beginning to be able to ingest any kind of data. So if we have Sentinel-1, perfect, put it in the model. If you don't have Sentinel-1, put Sentinel-2. If you don't have any of those, but you have drone images, put the drone images, okay? So our models are very flexible also in this sense, in order to be available at any time.
A quick note on drones and satellites. It's another complementary information, but you have to keep in mind that satellites monitor, while drones are good for inspection. Go there and give me the information right now of that thing, but you have to operate the drones, while the agencies already operate the satellites. So drone is good for inspection, and it's complementary, and satellite is good for monitoring. Okay, just like a little note.
Well, thank you very much. I'm really pleased myself that I see, questions keep flowing, and the discussion was very interesting. So, which is for me, the message is feel free to reach out, to the team. I think in your presentation is available to everyone. I think, Laura. So feel free to reach out. I think was the message we wanted to provide with you, that there is a sort of an open framework to operate with. Satellite data, is a consistent source of big data, consistent, free and open. But of course, the best results, as the team indicated, can be achieved if combining with different data sets. Just by looking at your notes in the chat box. Several hints we got, to include other data sets, to make the analysis more refined. There is an opportunity there. But again, I would like to thank everybody. Unless there is any final closing remark by Alfredo. Alfredo, do you wanna? What was your feeling? I don't know if Alfredo is still here.
Yes, I'm here, and I'm enjoying very, very much, really, this fascinating discussion, really. I think we have learned a lot, as we always try, and very participatory. Thank you so much, really, Juan, Laura, Ana, and of course you, Paolo, for actually moderating this LEAP meeting. Is really fascinating, and I think very useful and practical for many of our colleagues. The amount of applications I think that we can use is incredible, and I think we need to keep learning and keep communicating with you. Definitely from Southeast Asia, and I know from the other departments, we will do that. So thank you so much to all of you, and to all the participants. I hope that you join future LEAP events. As you can see, they are just going to the point, and the idea is to just keep sharing knowledge and keep learning. Thank you so much.
Thanks a lot.
Thank you very much.
Thanks.
Take care.
Thank you to everyone for the participation.
Thank you.
Bye-bye.
Thank you.
Thank you, Dulce, also for organizing this.
Thank you.
Thanks.
Fantastic.
Excellent.